more students joining. Send your emails about your homework 3 and you need to submit. Yeah, this times I change a little bit. So on one paper, and sometimes you start your team project, and each part is 1 page. And if you take a look at the homework, like the first one is a paper. It's my our previous paper. The paper's method has been widely used by some other research group for muscle, heart, and even could be used for brain and for the hemostasis, for heart tissue, for the skeletal muscle regeneration. And meanwhile, it's also the papers like, if you take a look at it, because we know like some students already there about the soft robot. And this paper, we also use the, in this research, we also use the materials for a macro porous and magnetic driving robot to deal with some the ocean, I mean like the oil water separation, and to deal with the some pollution issues, oil leaky issues in our environment. That's a pretty interesting paper, and we did several years ago, 3 years ago, and and published in a top research journal, in advanced materials. That's one of the best, and in the materials area, that's a research journal. So you can take a look at it as your homework. That'd be good, definitely good. Be helpful for your project. Meanwhile, in your project part, so this time only 1 paper, and the second part is also for 1 page summaries for your team project. That means like you need in next week, you also need to submit a title. What is a specific title of your project? And meanwhile, think about what will be your objectives. So if you can still have questions, please go back to some the project slides. And meanwhile, you can ask me in this Friday. Today's we have a team meeting, and then also before next Friday, you can, or your team can also book a time with me. We can discuss before your submission. Any question? And meanwhile, to cross this research topic, Kara asked me the question, research report on our topics. This research report on our topic. Yes, you're right. Not making proposal, that's your research topics, but that part will be included in your research proposal. So that's your research proposals part. And I just like before your final submission. So we need every week, we need to make some progress, right? Is it clear for you? Yeah. Ryan, are you there? Okay. And let me, So meanwhile, some students ask me the midterm questions. Right now, as I would say, safely say, because we have reading some papers, we have some general concepts about the tissue engineering right now. I will talk to you that the midterm time is next Friday. So next Friday, I will post midterm questions. And the questions pretty similar to your homework. And you need to do by yourself or independently and submit Monday, you have 72 hours to finish. Any question? Yeah, so before start today's lecture, let me stop my video. And so in the question you can ask me, and in the team or like after class or whenever, So let me share my screen. Okay. And that's, Let's open this one, t-shirts. So let me recap the, can you hear me? Or can any students can confirm my shared screen?
Yes.
Okay, perfect. And so that's the first is a recap. So we know like what is tissue? Yeah, generally we say is 2 or more type of cells. We call tissue. 2 or more type of tissues is organ. So that's like a skin is organ. And meanwhile, we introduce and the cell membrane because the basic unit of tissue and organs is cells. Cell have double layer, bilayers, and the inside is hydrophobic, outside is hydrophilic. And we know the energy machine is mitochondria, and nanoparticle research generally focus on lysosome for a lot of research. And in all, like in the tissue nuclear research, biomaterials research, generally we need a histological staining. So histological staining is like a slide. You cut the tissue with a microtome, a machine. The machines can cut a tissue pieces. Each piece is around 5 micrometer thickness. Then coat onto a slide for some treatment. And after treatment, we use a chemical for staining. And the tissue or cells will show different color. So that's a histological way. And the generates like we talk about is the connective tissue, epithelial, muscle, nerve, generates only this one epithelial is we say it's a spontaneous regeneration. It means like general epithelial can be regenerated by itself. And muscle, nerve, connective tissue, any kind of things will have like scar tissue will be formed. So here's like I would say if like the nerve have some tissue got some injured in the brain, the scar tissue will be produced. If we know the scar tissue is a lot of collagen fibers and they have pretty high stiffness. So in the brain, scar tissue happens. Yeah, that's a stroke. It's dangerous. And the tissue, we know like the muscle, epithelial, also we talk about a little bit, in the like this one, there is a base membrane between 2 tissues. Generates like that's the cells like this one is typically a base membrane. So we use TEM or SEM to make the investigation. And also we talk about some like connective tissue, some loosely dense or elastic, but generates have 2 compounds. One is collagen, one is elastin, elastic fiber or elastin, collagen, elastin. So they're different, cadensity, different densities and alignment or non-alignment, and elastin fibers percentage decide the materials, the tissue, the connective tissue is loose, dense, or elastic. So we have like different, for muscle nerve, between the packing tissue and the strong, like in the heart valves, there's a dense, and the elastic blood vessel, blood vessel, air passage, airway, and you will see that's a typical histological staining. You take a look at, we have like very dense, like this one is elastin fiber, loosely, so loose connective tissue and the dense connective tissue. So that's you can, obviously to take a look at what tissue look like using histological staining methodology, and generates like dense connective tissue, like a tendon, and adipose tissue. That's another very interesting materials. You will see like this one is a sphere-like structure. They are packed together, form and the nucleus a little bit. That's the nucleus. Like this one. So protect the cohesion for organs, insulating layer in skin, storage of fat reserves, and the connective tissue like a bone. A lot of beautiful patterns there, and from osteoblast and from lamella. That's kind of lamella structure. One lamella, like this one, and inside is a blood vessel in canal. Harrison canal structure, and like this one, you see, lamella structure, like this one. Okay, the blood vessel, slow there, like this one. The capillary, that's blood vessel, and generally these layers for research is very interesting materials. The epicellular layers provide a lot of kind of like very active, like a stem cell kind of, there. So we always use this way in the tissue regeneration. We can use the one for bone, for cartilage. If you take a look at the movies, did you guys remember the movie for the cartilage? Young people, his mother is a nurse. And get like in North Carolina, and the doctor made a surgery for him, and you see like the first one, the doctor, the surgeon, take the cartilage cell that's from healthy cartilage, and meanwhile, they proliferate the cartilage cell, chondrocyte cell, into enough number for implantation, then injection in the pocket. So what are the pocket materials? Generally, pocket materials use this way. Use this one to make the pocket, the epicellular tissue on the bone. With mechanical strength and very healthy, with lots of collagen there, and use this as a pocket suture to the defect of the joint. Then in this pocket injected the healthy proliferated cartilage or chondrocyte cells into that for the cartilage regeneration. And we have the cartilage, the cartilage generates it's kind of chondrocytes. We have 3 type of, that's like and the cells in the Zero-Kun structure. And right, move to the second, another type is epithelial. So epithelial could be like a single layers, like we can the squamous, very simple, okay, general cubicle and a chromolar. So the a single layer, and like this one, they can squamous as a lining of blood vessel. That's we saw the endothelial cell, endothelium, okay. endothelium. And the heart and the cavity of the body, so generally it's like, very thin and so a platform kind of structure. So the purpose is to reduce friction between surfaces. And the cubic, like this one is a small ducts for like cerebral glands, like this one, and the main glands, they can have, they can secrete, some kind of mucus. So mix the gland, that's one secrete some chemical or some the materials, and protect the underlying tissues and the non-secretory or form watery secretion and some enzymes. And also like here is some mucosal glands and for viscous lubricant protective mucus. And that's why it's like a columnar kind of structure. It's a large ducts of kidney and the surface lining of stomach. So they were like, one is like a protect for the kidney duct, protects and lines and secretes water for the stomach. Yes, alkaline because to protect stomach from its own acid. So think about this one. Sometimes like with a soft robot, to take a look at what like the mucus, they distribute. If like some chemical pH value changes, your soft robot can make detect and send information to the doctor for identification of some disease. And so this one is a simple squamous epithelium, like this one, structure. That's the nuclear, right? Nuclear and the cell boundary. It's like this one. If cross section is like a very thin layer, so that's a typical histological staining. And that's the general happens. A thin sheet-like layers, right? Minimal resistance to diffusion has been called the pavement epithelium because they can look like a paving stool seen from above. So a lot of things like for the lining of peritoneal and the pericardial cavities and a lot of things, like this one, the capillary. That's for blood vessel or the lungs, the basic airway structures and the kidney. So here is like a cuboid. So that's like structure a thick, a little bit thick, but general function is similar, like this one. It's a columnar is even wrong, like this one. Okay, so like a small intestine. Because columnar cells are quite thick, you see they're quite thick, okay? They do not radially allow passive diffusion. So generally we mention this way is like, what is a passive diffusion? Passive diffusion is like based on the thick diffusion series. If there ways we have a high concentration, we can passive means like, you can diffuse into low concentration. But for thickness, for those, columnar cells, so generally with active. That means like use a cell for movement, to move nutrients through them from the intestine to the blood. So need like active absorption to help with this. They need like some like microvilli structure. This one, the structure, okay. And simple columnar epithelium. So this section through Asia, like this one, gallbladder. That's in the kidney urinary system. So this is a real simple, columnar epithelium and outline the connect tissue, like this one, And the epithelials like could be like if more kind of complicated, they can combine it together for like a transition. So that's the urinary, as already in last slide, we say that kidney, urinary system passages. So you will see like this one, a little bit transition. And extensible, protective, that's the general, prevent the penetration of urine into underlying tissues. And straight, you see a line, more line, layer by layer, kind of like this one, from little one to a line, So the surface is subject to great wear and tear, that's and the internal surface of mouth and some other tissues. So most are resistant type of epithelium protect against friction. So think about like if you want in the future a robot, if you want like have a very low friction, so you can think about this kind of tissue you can follow, and to make a biomimetic, very smooth robot. And that's the conified external skin, and that's one's no cells. Okay, that's real. Sometimes it's the data part of the skin. Every day, this one will be come off, then grow a new one, but no cells there. Then more cells. So protect against the well and tear evaporating and the extremes of the temperature. Like we said, dead cell layers, very right in thickness. That's our human skin first layer. In epithelium. On top of the epithelium, there is we call the specific layers like that's like no cells and all dead. That's the stratified squamous epithelium. So this one's examples, of this one. You see? From the esophagus of the cat, and arrow shows the nuclear. That's one's the nuclear. Okay, that's the nuclear structure. Nuclear of the outermost layer. This is normal for mucosa and the most stratified squamous cells in other areas, skin. As we say, it's like outermost lose their nuclear, that means a beta cell, right? And the epithelials for the pseudo-stratified columnar ciliated, that's the ciliated hair kind of structure. So it's for respiratory passageways, like this one, a lot of, And for protection, cilia can form current to move some materials like mucus, trapped particles toward the mouth. This one, the cilia structure. Again, that's the pseudo stratified, you see, right? And we have kind of cilia. So this example is a ciliated pseudo stratified columnar epithelium from the trachea. And the arrows you can see show the layer of the cilia on the surface of the tissue. Now we move to muscle. So all have like elongated cells with a special development of contractility, like with actin filament, smooth and unstraight, or like the involuntary muscle, that's the least specialized, and like this one is the nuclear, you see, but it's a long cell fibers, okay, the long cells. And that's like for this, smooth muscle, that's the slow rhythmical contraction, relaxation, and founding the wall of the visceral organs and the blood vessels. So it's the blood vessel part, right? And the cardiac and the heart muscle. So it's more highly specialized, rapid rhythmical contraction and spread through the whole muscle. You see, like differently, you will see a kind of straight kind of structure like this one. And they have a pattern, right? They're bundled together. Yeah. So found the heart wall. So that's not under, voluntary control. And so this one is a straight, stripped. Yeah, like this one stripped. Or skeletal muscle. Yeah. You see this one, that's the one, the heart muscle. And the bigger, yes, more kind of, yes, structures like this one. And most highly specialized, very rapid, powerful contraction of individual fibers. So a lot of individual fibers make a bundle. And the thick covering the membrane, we call that, the sarcoma, or sarcoma. So it's a very long, large, multinucleated units and no branch. You see the cross, straight the structure, the fibers. So if you take a look at the details like a muscle, we see the smooth involuntary muscle. But like this one is more kind of, directional, skeletal muscle. And you will see like, we see like the cross-stretched fibers. And the cardiac is not specific like skeletal muscle, but also with some direction. Like this one, that's the nuclear. And the fibers, there's. So here's like a little bit more about skeletal muscle. You see that, they can, fiber, yes, a long fiber and the blood vessel. That's different. So think about your project. Brain, heart, we know. Always think about if you want to let your brain tissue and heart tissue can survive, or like the heart valve, always think about the blood vessel need to grow inside.
Question.
Yes.
What's the difference between strained muscle and the regular smooth unstriped muscle?
Which one? This one, regular smooth muscle. You will see like you will see like this one. This has a specific pattern. Yes. No, this one is no. General muscles no kind of. So straight that provide more kind of contraction force. That's typically one way. Another one's like for the straight the muscle generate or skeletal muscle generates like a lot of long fibers. So for general smooth muscle, no specific like with fiber, but it's not like this kind of skeletal muscle or the fibers, with a long aligned direction. Is it clear?
Yeah.
Okay, perfect. So think about like a skeletal muscle, contract force. Heart muscle also has, cardiac muscle also has, and you will see like the muscle fibers like this one, and they if you take a look at inside, they have still very beautiful some kind of self-assembled structure, aligned structure, and with a membrane to separated from each other. So the nerve, even like a bit complicated. Typically, we have like before that once, like I can give you a short movie. It'd be good for you guys to. So we have share movie and so the cardiac muscle first. Just 2 minutes.
They are made up of striated uninuclear cells joined end to end, forming a network. Cell junctions are called intercalated discs. The cardiac muscle has
This one, intercalated discs, is very important. If you want to generate a heart tissue or cardiac tissues. And after like 2 weeks, after 2 weeks to 3 weeks, we generally use the TEM to take a look at. This disc is formulated. If formulated, that's a good sign your heart tissue is get regenerated.
Gap junctions. The arrangement of actin and myosin is not as organized as the skeletal muscle.
So that's like a
It
bit different.
contains sarcoplasmic reticula, transverse tubules, and numerous mitochondria. The sarcoplasmic reticulum is less developed than the sarcoplasmic reticulum in the skeletal muscle and stores much less calcium.
So in the heart tissue, so we have some specific facility to check the calcium or calcium ions change, like real time to take a look at Ca calcium ions concentration change, and use this way to determine the heart tissue healthy or still some issues.
Physiology of the cardiac muscle. It consists of self-exciting tissue. It has rhythmic contractions, 60 to 100 beats per minute.
So that's like if the heart group, if you take a look at the previous, we talk about the movies, you will see if you can see the heart cell or myocyte, cardiomyocyte, CM cells, and on the collagen film. So when the time, like after 72 hours, they can beat together. So that's the ways to, work with the muscle and together form the contraction.
It is involuntary and has all or nothing contractions. It pumps blood to lungs for oxygenation and to the body for distribution of oxygen and nutrients. Excitation-contraction coupling of the cardiac muscle. The action potential spreads out through the cells and across the surface of the sarcolemma via gap junctions. Voltage-gated calcium channels are present in the sarcolemma that get activated. Calcium diffuses into the intracellular fluid from the extracellular fluid. The free calcium present in...
So this one's action potential is very similar to like active diffusion. And with like electronic potential change, sometimes like maybe a proton increase, concentration increase, decrease, and to release some calcium, for example, or some chemical materials.
Cellularly activates voltage-gated calcium channels of the sarcoplasmic reticulum. The calcium diffuses from the sarcoplasmic reticulum to the myoplasm. The calcium that diffuses into the cell and the calcium that diffuses through the calcium release channels attach to troponin and initiate contraction.
Yeah, so you will see the calcium to provide kind of signal for the muscle contraction. So that's the first part for the cardiac muscle. Then we go to the skeletal muscle.
Skeletal muscle, also called striated muscle because of its striped appearance under the microscope, is used to move the skeleton. Skeletal muscles are under the direct control of the nerve.
So that's another ways. We will generally use a skeletal muscle to simulate skeletal muscle for robot actuate. And generation right now, a lot of research about robot project research industry or in the institute. They want like more kind of learn more kind of ideas from the muscle structure and contraction and stimulus and borrow that ways applied to a robot muscle. That's really humanoid or human-like muscle by robot research and development.
System and can produce contractions ranging from quick twitches to powerful sustained tension. Individual muscle cells, called muscle fibers, are among the largest cells in the human body. Ranging from 10 to 100 micrometers in diameter, each muscle fiber runs the entire length of the muscle, which may be as much as 35 centimeters or about 14 inches in a human thigh. Each muscle fiber, in turn, contains many individual contractile subunits, myofibrils, extending from one end of the fiber to the other. Each cylindrical myofibril is surrounded by sarcoplasmic reticulum, a complex of membranes forming a...
So like this one, sarcoplasmic, that's typically kind of like a TM or ACM we want to take a look at for the skeletal muscle regeneration. So skeletal muscle regeneration always combined with some nerve, such as we talk about the next one. And if like electronic signal cannot make a transmission between the injured skeletal muscle, the muscle will get trophy. So it means like the muscle function will gradually lose.
Complex of membranes forming a network of interconnected hollow tubes. The sarcoplasmic reticulum contains a fluid rich in calcium ions. Deep indentations of the muscle cell membrane, called transverse or T-tubules, extend down into the muscle fiber, passing very close to portions of the sarcoplasmic reticulum. This arrangement of T-tubules and sarcoplasmic reticulum is crucial, as we will see, to controlling muscle contraction. Myofibrils contain subunits called sarcomeres made up of precise arrangements of actin and myosin filaments. Sarcomeres are attached end-to-end throughout the length of the myofibril, and their junction points are called Z-lines. Attached to the Z-lines are strands of actin and two accessory proteins that form the thin filaments. Suspended between the thin filaments are thick filaments, composed of the
So this kind of actin filaments, interestingly, very similar to some microtubule or cytoskeleton in each single cells. Yeah, that's very amazing things. Yeah, and only even more amazing like the macrofilament or microtubules or cytoskeleton in single cell. They can change rings automatically based on the environment. They can, for example, like a polymer, they can make a polymerization, make a long chain, then quickly depolymerization. That's reversible. Yeah, that's a lot of research scientists work on, but still the mechanism is still elusive.
Myosin. The alternating thick and thin filaments give myofibrils their striped appearance. Small arms, called cross bridges, extend from the strands of myosin and contact the thin filaments. The actin protein of the thin filament is formed from a double chain of subunits resembling a twisted double strand of pearls. Each subunit has a binding site for a myosin cross bridge. In a relaxed muscle, however, these sites are covered by two accessory proteins, which prevent the myosin cross bridges from attaching to the thin.
So if you take a look at several years ago, several scientists in Europe, United States, and Japan, they got Nobel Prize in molecular robot. Molecular robot, the idea is from muscle actin, myosin, their movement. And they using this similar mechanism to develop on a few molecules. And in this way, to explore some specific movement. That's it. That's a molecular robot.
But when a muscle contracts, The accessory proteins on the thin filaments are moved aside, so myosin cross bridges can attach to the binding sites on the actin subunits of the thin filaments.
Yeah, so that's the one part. Then we go to the epithelial layers.
Major types of tissue in the body, and it can be found throughout many parts of the body. It lines many of the structures of the respiratory tract, such as the trachea, bronchi, bronchioles, stratified squamous epithelium, in which the top superficial layers of cells are dead. As new cells are produced in the basal bottom region,
Oh, why go to this one?
bronchi,
Yeah.
throughout many parts of the body. It lines many of the structures of the respiratory tract, such as the trachea, bronchi, bronchioles, and alveoli, which are the tiny air sacs in the lungs. It also lines most of the digestive tract, the epidermis of the skin, the oral cavity, and many of the glands in the body. Epithelial tissues have some common characteristics. It is comprised of tightly packed cells with very little extracellular space. They also have an apical or free surface that is exposed to an internal body space or the external environment, and a basal or deep surface that is attached to a thin basement membrane which is connected to connective tissue, as you can see here. They also lack blood vessels, which is called avascular, so they get nutrients from their apical free surface or by diffusion across their basal surface from the underlying connective tissue. Epithelial tissue is also innervated.
So you see that basement is just a membrane. And with type of collagen, for examples. And to separate the epithelial tissues from connective tissue.
Means that they have a rich supply of nerves, and epithelial cells can reproduce themselves, which is important because they go through severe wear and
So
tear.
that's we say
such as
epithelial tissue can spontaneously regeneration.
in the skin and the respiratory and digestive tracts. Epithelial tissue has several important functions. It provides protection, as the skin protects the internal body from bacteria and other harmful substances. It provides sensory functions in the skin, nose, eyes, and ears. Epithelial cells are also important in secretions.
So that's like another one's like for the e-nose in the future robot, electronic nose. So biomimetic ways we can use this way, to make a biomimetic nose for a biosensor for future smart robot.
They secrete hormones, sweat, digestive juices, and mucus. And epithelial tissue is important in absorption, such as nutrients in the gut and the exchange of gases in the lungs. Epithelial tissue can be classified based on their cell shape or their number of cell layers. Based on shape, they can be squamous, which are flat, wide, and a bit irregular. These are found in the air sacs in the lungs. They can be cuboidal, which are similar to a cube, about as tall as wide, and have a spherical nucleus. Columnar cells are taller than they are wide and have an oval-shaped nucleus. Pseudostratified cells, as you can see here, have varying heights, as not all of them reach the apical or top surface, but they all do connect to the basement membrane. Some epithelial cells may contain goblet cells, which secrete mucin, which forms mucus that helps with lubrication and protection, and some cells have extensions called cilia, which are sensory organs and also provide movement of mucus away from the lungs and toward the mouth. And some epithelial cells have tiny finger-like projections called microvilli, which is often termed the brush border. Microvilli helps to increase the surface area for digesting and absorbing nutrients in the intestine. Based on cell layers, epithelial cells are classified in 3 different ways: simple, stratified, and pseudostratified. Simple epithelium is only 1 cell layer thick, and all cells are in direct contact with the basement membrane. There is simple squamous, simple cuboidal, and simple columnar epithelium. Stratified epithelium have 2 or more layers of cells. Only the deepest basal layer cells have direct contact with the basement membrane, and their formation looks like a brick wall. This formation provides better structural support and protection from wear or tear. Again, there are stratified squamous, stratified cuboidal, and stratified columnar epithelium. And pseudostratified epithelium is comprised of pseudostratified cells we discussed earlier. 2 other notes regarding epithelial tissue. There are also transitional epithelium, which can be in a relaxed or stretched state. In a relaxed state, they have umbrella-looking rounded cells at the top apical surface, and the bottom basal cells appear cuboidal. In a stretched state, the top cells flatten and appear squamous. Some of these cells will also have two nuclei, and transitional epithelium is found in the urinary tract. There is also what is termed keratinized stratified squamous epithelium, in which the top superficial layers of cells are dead. As new cells are produced in the basal bottom region, they migrate to the top, and they produce a protein called keratin. These cells fill with the keratin, which make them very strong, but they lose their organelles and nuclei and
So
die.
that's like we found the cells that on the skin. Generally, it's like when we take swallow the medicine from oral, and injection have some not so convenient and some side effects. Right now, a lot of like clinic right now and research focus on the dermal drug delivery. I mean, like from skin, make a topic on the skin and for drug delivery. So one way is use a microneedle. So microneedle is interesting, like they penetrate this keratin or keratinocyte or keratinized cells. That's very hard because the dead cell layer. When they penetrate this layer, go to a little bit of dermis layer, you will not feel any pain. But the drug have been high efficiently delivered to the body. So that's like currently quite
Epidermis,
popular
or outer
in
layer of
clinical
the skin,
application.
consists of keratinized stratified squamous epithelium. As you can see, epithelial tissue and its cells have many different forms that fit its many different functions in the body. And that
So
is
that's
the
the
basics
epithelium.
on the epithelial tissue.
And let me go back to the last several slides for the nerve. So the nerves, you will see the cell body, the typical nerves for motor, and we have like the body, control the metabolize the whole unit. You can see like this one layers, this one definitely we call that, like this one is a danger light, and to gate or ingoing impulses, that's the cell process, then to like that, go to the axon, the main conductive fiber. So like electronic signal transmission, and the axon bundles of this make up the peripheral nerves. So we have the myelin, the Schwann cell, this one, and the axon inside. So how this one? This one is like if you look like electrical wire, right? And the copper inside, that's the axon. And outside is the insulation layer. That's the myelin, the myelin layers. That's for protection. For the protect or to give like insulation. To avoid, to protect from each nerves get interconnection. And like if like a nerve like this one, another nerve goes this one, they have a shortcut. But we have a nailing like polymer, polypropylene, PCL, to provide the insulation layers. And the nerve endings like the model and the plate like this one, So the nerve impulse stimulates contraction, and also good for skeletal fibers. So generally, it's like in the central part of the cell body, but from axon. And meanwhile, if we get like signals from danger light, and then give a signal to the muscle. And the nerve, like this one, you see, and throughout the nerve cells, the neuron, a large arrow, and from spinal cord, and small arrow is like surrounding neurologic, neuroglial cells. The neuroglial cell is like a fibroblast cell, okay? And this one's, if this one overgrow, right now, no way. Yeah, a kind of cancer. Yeah. So here's like you see the exons and MS. The marinated structure that's provide insulating. So that's today's lecture, and we're gonna see you in the in afternoon tutorial class, and same times for each team, and I will answer questions for you, and I'll provide my suggestion, and also like give you guidance, how to start your project and start your first team project, first page homework, and so if no questions, class is over, and see you afternoon.